Welcome to the Broken Authentication course. Here we are going to start learning different techniques, how we can bypass the access control. As you remember, access control means authentication, authorization. Those different steps, we're going to be learning how we can get into systems, web-based obviously, without authorization. How many techniques we have in order to do that. It's a must-know knowledge when dealing with web-based and any other type of systems. Always we want to get unauthorized access to those systems to prove lack of security controls. My name is Daniel Regalado, and I am the lead author of Grey Hat Hacking Book 4th edition, and it's my pleasure to teach you this class. So the agenda, we're going to talk about the definition as usual, what is broken authentication, what we can do with those kind of issues. We're going to talk about online brute force techniques, offline too, some authentication bypass techniques. We're going to be talking about SQL injection, but not as a classical way. We're going to be dealing with some ways to bypass to bypass security controls via SQL injection. So let's talk about the definition. What is broken authentication? As I said, it's vulnerabilities found during authentication and authorization phase. What is authentication? Is when you present your credentials to a system pretending to say that you are this specific user with this specific password. That's authentication. Presenting your credentials. And then once you are authenticated, you move to authorization. Okay, I am a valid user. What I'm able to do, what are my rights, my permissions within the application. In those different steps, we can find ways to bypass security controls. Those issues are commonly found in login pages, in the feature which is forgot password, if you remember, change password, pre and post session cookies. That means when you, for example, get into a server and you get a cookie which is unauthenticated, and once you log into the system and the same cookie is used after authentication, that's an issue. We will explain a real scenario. We can break authentication by a couple of techniques. One is cracking, dictionary-based, with a set of passwords to be used. Brute force, obviously, combination of different passwords, trying to get access into the specific system. Rainbow tables, which is a set of pre-calculated hashes stored in tables which can be gigabytes of size. So basically, you run specific clients to look up in those tables, and for specific hashes, you have the corresponding password. So that's the way it works. The problem here is those rainbow tables are really big. You need to buy them sometimes. But it is another approach. GPU-based attacks. Hashcat, one of the best tools. GPU is using your video card, which speed up the process of cracking, is pretty useful. That's for offline attacks. So as I said, we have online and offline crackers. We're going to have some examples here. We can also break authentication, obviously, by doing SQL injection, which is one of the most common techniques used when dealing with web-based attacks. But it's not the only one. As I said, we have other options. So let's talk about brute force via burp. Burp is our proxy. It's not only a proxy. It can do many other things, but we're using it here just to brute force the login form. So the way it works, we load a burp with a sniper attack in a specific tab, as we can see here. Basically, we intercept the request, in this case the post request. We select the post parameter, in this case the password parameter, which is going to be replaced with a dictionary-based list of passwords, trying to find the right one. Once we do that, in step 2, we go to the payloads tab. in the Payloads tab, we can upload our dictionary of different passwords. Kali comes with ROCU, which is a set of around 300 megabytes of well-known passwords that we can use. And finally, we run the attack. Just by starting the attack, Burp is going to try to test all those different passwords found in the dictionary. And if found, we are going to be able to find the password and then able to authenticate impersonating a valid user. It's not the only one, Burp. We have Hydra. Hydra is pretty cool. Also comes with Kali pre-installed. It's an excellent online password cracker. It supports multiple services, not only login forms. You can do FTP cracking, Cisco, DBs, like Oracle, MySQL, Microsoft SQL Server. It supports POP3, which is the email server, SMB for Windows, SMTP, which is the, again, email server to send emails, SNMP, which is a protocol in the network, mainly used by routers, SSH, SVN, Telnet, BNC, Postgres. So you have multiple options to use with Hydra. Basically, we will have an example here so you can see how we can use it. For example, if we want to crack the login form, the username and password that we don't know it, we need first the full URL that we are going to attack, in this case the login form, then the service, if it is HTTP or HTTPS, the method, get or post, and of course the parameter or parameters that we're going to try to attack. And we need a failure or successful response. That means Hydra needs to know when it was able to find a password. And the only way to know it is by understanding the response. So let's say that you provide a valid username and password and you will get a welcome user. Hydra needs to know that, because as soon as Hydra see a welcome user, it knows it found a password. So we need to provide those details to Hydra during the attack. So let's see an example here. We have Hydra, the IP. In this case, we said that it is a form post. Then we said that it is in the dir/index.php. We said that the parameters are user and password. And you can see those specific uppercase user and pass. Those are variables that are going to be changed at runtime with the list of users with -L and password with -P. Okay? Very important, after the pass, you can see the invalid username. That's the expected failure response. So that Hydra keep iterating until it finds an opposite response, which means it found the password. But you can also provide a successful response, like here. Instead of saying invalid username, you can put a prefix S equal, which means successful, and then you can say to Hydra, which is a successful response, so that it can know when it finds the proper credentials. Here is just an example how we can run it. And at the end, you can see that it founds the login with password. We're going to have some examples in our labs so that you guys can play with those things. Cracking htaccess. That's another very cool one. htaccess is a feature in web servers, mainly Apache, where you can restrict access to specific directories. In order to access those, you need to provide the valid credentials. Sometimes the access control for that specific file is not proper configured, and then you can retrieve it from internet. If you retrieve it, sometimes, as you can see here, it's not plain text. It has a specific algorithm to encrypt it, which can be easily handled by John the Ripper. John the Ripper is our help in offline cracking efforts, and we can just pass it to John, like in this example, and in a matter of seconds, depending on the password, we can crack, and in this case, know that the password the admin user has the password in this case. And that can help us to get access to unauthorized directories, which sometimes can give us more information into the web application. Now let's talk about some bypassing via SQL injection. As I said, we have our course about SQL injection. We are not teaching SQL injection here. We are just telling you ways to bypass authentication. Like in this case, here there is an issue in MySQL with the type conversion feature. It's exploited via SQL injection, but the root of cause of the problem is in MySQL. Let's see how that works. So we tested it in MySQL 5.5, can work on other versions. So we don't need to know the username or password. And let's see how it works. We need to be able to inject a single quote. That's as any other attack. This is the requirement for this one to be success. Okay, so let's see how it works. We have this specific SQL query which says select everything from users where user equal admin and password not valid. That means we don't know the password. We just know the user is admin. Let's have that as a specific requirement. Then we can see that since we don't know the password, MySQL internally is going to convert that specific query into something like select everything from users table where user equal admin and 0. 0 means when it evaluates the pass equal not valid, since it is not a valid password, that returns false, returns 0. That's why we have user equal admin and 0. Admin is 1, which is true, and 0. That means 1 and 0 is false. We don't get access, okay? Let's see another example. In this example, we have end pass equal not valid equal anything. So let's see how this works. The expression is going to be evaluated from left to right, okay? So MySQL is going to say, okay, user equal admin, yes, that's true. Then it's going to move to the right, and it's going to say, okay, password equal and not valid. That's 0, which is not true. And then it's going to say, okay, 0 equal to the right side. As we can see in the right side, we have anything. But then MySQL is going to say, okay, in order to compare the 0 in the left with the anything in the right, I need to do a type conversion. I need to convert this guy into a number, into a double is the way it handles this. But when MySQL is trying to convert anything to a number, as you know, it's a string, it's going to fail. And therefore, the anything is going to be 0, which ends up giving us the final comparison of 0 in the left, which we already had, with the 0 in the right. And therefore, it's going to end up saying 0 equals 0, that's true. And therefore, we're going to get a user equal admin and 1. And therefore, we get access to that specific application. Okay, so that was an issue, as you saw in MySQL. When it is trying to convert into a numeric number, it just do weird things, which allows the attacker to get access. Here is another one. Multi-byte injection is nothing new, but still very important to know about it. So let's see how that works. Normally, a byte is represented by a char, right? We can say decimal 65 is equal to letter A in decimal, for example. But when we talk about multi-byte, that means it's not only 1 byte, it can be 2 bytes, which still represents 1 char. 2 bytes, 1 char, or more than 2 bytes. That's called multi-byte. Okay, that represents larger char sets. Char sets are like alphabets, like in Asia, Chinese ones. Those ones, they have a larger char set, so they need to use all those different multi-bytes. 1 byte can represent up to 256 characters, but with 2 bytes, you can represent 65,535 characters. As you can see, you can increase the char set just by adding 1 byte. Okay? Unicode, with its UTF-8 implementation, is the most well-known multi-byte encoding scheme nowadays, which is the recommended one to be used, by the way. So let's see what is the problem. So we have an attacker, okay, who is going to send this specific request, %BF and a single quote. When it gets to the web server is able to understand UTF-8. So it says, well, I don't know what is this, but I know that the single quote is malicious. So I'm going to escape it with a backslash. As you can see in the next step, it says, okay, so %BF, I don't know what is that, then backslash, single quote. Then the request gets into the database. But the database speaks Chinese. As you can see, the application server understands UTF alphabet. It's like one guy with this idiom. And then the database speaks Chinese, which is a totally different way to see the characters. Because it speaks Chinese, it says, you know what, the %BF slash, to me, that represents 1 character, 2 bytes, 1 character. So what it's going to do is it's going to change the %BF backslash with that Chinese symbol, whatever it is. And then it's going to leave the single quote alone. That means the attacker is able to inject the single quote and do all the malicious actions. As I said, the DB engine is going to say %BF slash. To me, that means %BF 5C. 5C is the hexadecimal representation of backslash, and then it is translated into that Chinese character. With that, what we are doing right now here is we are removing the escape protection implemented by the Apache PHP application server. We remove it, and therefore we can inject a single quote into the database that in SQL injection is key in order to compromise the DB engine and the web application. So we can see here how you can play with multi-byte injection so that it can break authentication. Session management, that's another way, issues that we can find here. So how it works, let's say that we have a cookie, we connect to, let's say, a bank. The bank is going to send us a cookie, not authenticated, a cookie, random cookie for us. Then we get the cookie and we send the cookie to a guy who has an account, let's say Bank of America. We get the cookie, we send it to this guy, the same cookie, we don't have access to that bank. That guy, let's say in a scenario, he takes the cookie, we can inject it via cross-site scripting. We can see those examples in that course. Once he gets the unauthenticated cookie, he gets access to the banking online application. And let's assume, it's not the case, let's assume that this bank is going to use the same cookie after being authenticated, and just is going to say, this is an authenticated guy. Then the attacker, since he knows that cookie, can connect to the bank and impersonate the valid online banking user. What we are seeing here is that this specific application is using the same cookie before and after, and that's an issue that can be exploited. Obviously, the recommendation here is always generate a new session cookie once the user is authenticated. It's a well-known issue, but still you can find those problems. And we, as a penetration testers, we need to make sure to test those specific problems. Okay, so let's talk about the mitigation strategy. As you know, guys, all about this whole knowledge is for us to be able to protect our organizations. We are the defenders. We need to be able to identify these issues and protect our companies. Recommendations, logon attempts restrictions. That means when you're doing a brute force attack with multiple usernames, passwords, you should have a logon threshold that says after 3 failed attempts, I just block that specific account and report it. That's pretty useful. Web server hardening, for example, we saw that the htaccess file was available for anyone. Permissions in the web server. It's important to also not only check the database, the application server, the web application, but also the file system. A strong password creation policy. The quickest the password, the easier and faster to find it via those cracking efforts. Unicode, UTF encoding, that's very important. As you remember, the PHP web server was able to speak UTF-8 encoding, but the database was speaking Chinese. It's like a mixed language configuration. So you need to put the same encoding across all the different components so that all talk the same language. And there is no confusion, as we saw in the multi-byte attack. Parameterized SQL queries is the same recommendation for SQL injection. It doesn't matter if MySQL has those design problems with the type conversion or any other issues, we can protect from the source code level. A strong access control, obviously, authentication and authorization. We need to put security controls in place to be able to monitor the persons being accessed, what are the rights inside, so that we can find problems. And well, let's talk about the summary, guys. We learned about different brute force techniques, online and offline. We talk about Burp, Hydra, John the Ripper. We're going to see those examples in our labs. We talk about how to bypass authentication techniques via SQL injection in this case, with some specific issues in MySQL. And we talk about the cracking of HT-PassWD, multi-byte injection, and MySQL type conversion. And finally, we talk about the session management issues so that we are able to handle the cookies unauthenticated and authenticated. See you in the next course. Hey guys, welcome to the Broken Authentication Lab. We're gonna be discussing some techniques that you can use when you don't have credentials, but you can brute force them online or offline in order to get unauthorized access. The idea is to prove that this specific web application doesn't have security controls in place. So let's start with the first example. Here we have Burp Swift. We're going to start using it for intercepting HTTP requests and response. So we go to proxy, we go to options, and here we say intercept request and intercept response. So we're ready to go. The browser, you guys keep in mind that you go to preferences depending on your browser, and in this case Firefox, go to network settings, and then you just enable it. Burp commonly by default listens in the port 8080. Okay, so here if you put any credentials, you will get the invalid username or password. Sorry, it is being intercepted. That was the error before. And here you can see in orange, intercept, that's the one that is being highlighted because is the tab active, in this case the interception. And we can see here that here is the path for the authentication. We just copy it, and here we can see the username and password. We can see other different HTTP headers, and we say forward. We get a response, invalid username and password. We let it go and then reach our browser and we get this. Okay, so we're gonna try to brute force the login. The way to do it via Burp Suite is pretty simple. Basically, first of all, you need to call the intruder module. The way it works is that you select your URL. In this case, we saw this post one sending the credentials. Right click on them and say send it to intruder. You can see that the intruder is in orange right now because it is waiting. And also the proxy here has some internet connections. I will just drop it, that's not our thing. And in the intruder, we go to the positions. Here the positions, you can see that Burp automatically selected all the potential entry points, which means something that it can change and test for you guys so that it can find vulnerabilities, like changing the session, the cookies. But we are more interested in the password sent. We're trying to find it. So we're gonna click in clear in the right side. So it removes everything. And then we just select the password field, sorry, the value, and we say add. You can see that it is wrapped with those two symbols, and that's gonna be changing. In the user, I'm gonna put admin, assuming that we know the username. And the reason of this is because for some reason I was testing Burp, and sometimes it was finding both passwords. Actually, it was not finding both passwords. Even if you provide this option, it was failing. I don't know the reason, but don't worry, we have other exercises with other excellent tools. So we are gonna use password only. The next option is to go to payloads, and here you need to load your password list. That password list is going to be printed here, as you can see. And finally, you just go to well, you can go to options and you can change. Something important here is like the redirection at the bottom. The redirection normally says if you find a redirection which happens after authentication, follow it. In this case, we are not going to follow it. We're going to leave it as it is. And finally, this is just another garbage coming from the browser. Keep in mind that we're intercepting everything, so that's why we are getting many requests. Here, we're going to go to intruder, start attack. It's something about demo. We're fine. We click OK. And you can start seeing how it is start testing all the different passwords. Eventually, you can see this guy, 302, which means redirection. Here in the row, we can see the request that we sent, admin and password. And in the response, we can see the 302, which is redirection. And therefore, you can see here the location, which says welcome. So that's telling us that we find the credentials. In this case, was password. Obviously, this is very simple, but keep in mind that you can do exactly the same steps for any other login form, and you can put a big list of dictionary-based passwords, and if you are lucky, you can get access. We just let it go and see it is admin, as we know, and the password is this, and that's it from here. And obviously that if you want to test it, you know, it is admin and then password. I'm just gonna copy this guy, paste it here, and I'm just gonna tell Burp to let it go. Request and response, and we are inside. So pretty simple but powerful. Feel free to play with that thing, and hopefully you find other ways to find credentials. Okay guys, so let's talk about a second approach. The second approach is not using verb, so I'm gonna disable it from here quickly. Here is the window. So the second approach is to use a very cool tool which is called Hydra. Hydra is a tool very powerful because it will allow you to crack dictionary-based attempts against multiple services. We're going to be using it just for HTTP post requests for web-based applications, but you can use it for many services. It can be FTP, it can be SSH, it can be SNMP, I mean multiple Samba or multiple services. You can see the slides of broken authentication to see all the other examples. The way it works is by, here I have the script here. So basically you will pass the host, then you will pass the type of request, in this case is HTTP post, then you will pass the URI where is going to be the script doing authentication, then the name of the user text box that is going to be sent the username, and the password. Again, the name is configured in the HTML of the password, and this is very important. This pass and this user are going to be substituted at runtime with the dictionary based list. Finally, we have here the message that is going to say when it's going to tell Hydra when it's going to be a failed attempt. That means that before you run it, you need to know exactly these kind of messages. You need to know where it is the invalid or the error message when it is not a valid credentials, so that you can give it to Hydra. Also, if you go to the source of the page, you need to grab also the name of the text where the user is going to be sent. In this case is user, and then the name of the input field of the password, in this case is pass. Those needs to be provided also to Hydra. So let's go and assign those values. Here we have the whole path. So we're testing this. Let's go and check it. We're gonna put, first of all, this long URI, which we just found, is a little bit long, and then let me put here just a backslash, sorry, a slash. Then we change here the text box name of the username, which I think is user, and then here, which I think is password. Let me quickly double check. Okay, it's user and it is pass. Okay, so, and here is pass, and the invalid username. This is a dictionary base of users, and for passwords this is just timeouts and threads, I think. This is the result if you want to save it. And actually, let me check the W option right quickly. You're gonna say, hey, come on, man, you're teaching me and you don't tell me. I think it's threads, but I cannot see it here. Probably, I know, it's gonna be here. Yeah, the W is time and the T is tasks in parallel. Okay, so you can increment the task so that Hydra can run more than, he's gonna run 10 times in parallel. So if we run this guy, you can see that right away come back and say, hey, I found the credentials, login, admin, and password. Right away it found it. And if it would have been more than one, it would have told you also. Finally, here I just want to show you that you can also pass
successful attempts, not only invalid. So here, instead of say invalid, you're gonna add an S, and you can say something like welcome, and then Hydra is gonna know when there is a successful attempt. But I didn't use it because normally in a real scenario you don't know a successful attempt, right? Because you're trying to guess the passwords. So in this case, you can see that different with Verb Suite. In this case, we can crack, well, dictionary-based brute force the username and password, not only the password. In Verb, it also does it, or is supposed to do it, but it was not working properly. So, anyways, we have multiple tools. That's pretty much it with Hydra, guys. So this is the third and last one. Let's say that you have a web page here, which is a specific place, right? That it is very common, it is protected, and you try to put something here, you will get nothing because it requires a password. Eventually, you won't be able to access it. This is controlled by a control word in Apache, which is called htaccess, and with htpasswd, which are credentials, basic authentication used. Those ones is a basic authentication that prevents access to specific folders in web servers controlled by Apache. It's not recommended to use it in sensitive files because it can be easy to bypass, and actually we're gonna see how we can do it. So assuming that you have access to that HTTP htpasswd file, let me show you how it looks. So this is one of them. It has the admin, the username is clear, but the password is not clear. It is encoded. Sometimes you can grab it from the web server directly because lack of file permissions. Other times you can find it because it was leaked somehow. There are multiple reasons, but let's assume that we have it. We can just tell John. John is a cracker, offline cracker, very powerful. It supports multiple formats: zip, RARs, Office documents, NTLM hashes, Unix hashes. I mean, multiple, and it's pretty good. It has multiple options, but in this case, we can just pass it this guy, and John is just gonna run, and you can see that it says no passwords left to crack. So then it says loaded one password hash, as you can see here. So that means it's found. It probably no. This is just to load it the first password, this hash, because what John is gonna do is gonna convert this into a hash that it can understand, and then after that it will try to crack it. It does the same for every single format. It will always, if it is a zip, if it is a RAR, if it is a Office, it will convert it into its own hash format and then crack it. So here we can say John -- show. Let me think. Okay, and the password file is this. So you can see that by passing the htpasswd and tell John show, it will show you if it cracks something. In this case, it was able to crack it, admin and password. Obviously, if the password is bigger and with alphanumeric, it's going to be more and more difficult, and it's going to take more time. But it is very helpful for many other occasions. So let's test it if that works. So we go to protected, we set admin and password. Well, it is pretty basic, guys. This is nothing advanced. It's just different tools that you can use in order to try to break authentication controls. Okay, so finally, let's talk about quick recommendations about those different hack attempts that we did. The first one was about Verb. We used Verb and Hydra in order to brute force the login form. And the first recommendation there is to implement maximum attempt failure, which means normally you will say, okay, if I detect that this specific user has had 3 attempts in the last 30 seconds or even less than that, I will just lock the account, will send an email to the administrator so that someone can take action. And then the user will need to call so that it can be reactivated. That way, you can prevent brute force. It's the best approach to do it. Also, definitely, you need to implement a good password creation policy, which must be, alphanumeric characters, special characters included in the password, must be at least 16 characters or at least 16 characters. It should not be a dictionary based password list. So those recommendations. The second one that we did was about using John in order to crack HT passwd. In that case, first of all, we need to make sure that that specific file, HT passwd, is protected. We should put right permissions in the file system so that no one can access it through the website, which is the worst thing we can do. And second thing, obviously, using directives. And let me show you one quick directive here, which we have in Apache. Sites enable default. You can see this is kind of the directives that you can use, like in this case protected, and then this is the basic required, and here you can see that it is the passwd, and you can, for example, here say deny from all, so that no one can access it. And this can be a configuration done inside Apache web server, just to enforce protection to a specific folder. But outside that folder, this guy sitting here must be only readable by specific users. Also, we can always use web application firewalls that, even though, like in this case, guys, in this case you can see that the www data user, which is the user running the web server, has read access. If we try to access it from internet, you can see that it says permission denied, right? The reason is because this web server is configured to not allow anyone to access this specific sensitive file. You can control sensitive files via web application firewall. We're gonna prepare a lab for you guys to do that, and basically you will restrict who can access this and many other sensitive files, like log files, access logs. That is very sensitive for you guys. So those are the recommendations, and see you in the next lab.